Let's solve a problem that isn't quite as straightforward. This question is not going to be asking for energy. It's going to be asking for something different. So again, let's read the problem carefully. A bowling ball with a mass of 8 kilograms is dropped. When it hits the ground, it has a kinetic energy of 500 joules. How high was the ball when it was dropped? So in this case, we're looking for the height that ball was dropped from. Let's go ahead and get just a little visual of this. We'll put our bowling ball over here, and it's going to be dropped, and the height is the question. All right, so we know that the mass of this object is 8 kilograms, and we know that it has an energy of 500 joules. Now this thing's being dropped, so at some point this may factor in, I don't know for sure, we'll go ahead and get it down. Gravity is 10 meters per second squared. So as I'm looking through how I can solve this, we're going to think about our energy pies for just a second. When this ball starts, it has some energy due to gravity. And then as it falls, that gets turned into energy that is kinetic. And we know that these two things are equal. So if we know the kinetic energy, we also know what the gravitational energy would be. So let's just say this is the energy that's kinetic, but it is also the energy due to gravity. So here's the formula we have. Energy due to gravity is equal to mass. Now, I like to have rearranged these formulas, so let's just spend a little time in the corner here. Energy is equal to mass times gravity times height. I'm looking for height, so I'm going to solve it for h. So I'm going to divide by m times g on this side, divide by m times g on this side. These will cancel, and I'm left that height is equal to energy divided by mass times gravity. So I'm going to rearrange that to get a formula that I can use, and I can keep that and use it anytime I want. So instead of working backwards up here, let's just go ahead and use our rearranged formula. And then we can substitute in our numbers. So we have 500 joules divided by mass, which is 8 kilograms, and gravity, which is 10 meters per second squared. Okay, let's go ahead and do our numbers. So 500 divided by 80 is going to get us 6.25. And then we end up with this weird unit of joules over kilograms times meters per second squared. Now, how in the world are we going to cancel that? Well, let's look back to another fact that we know. We know that a joule is equal to a kilogram meter squared per second squared. So let's substitute in, and let's just show this work over here in a separate area. Let's take our joule over a kilogram times meter per second squared. And we'll use this, we'll do our math up here to save a little space for our answer. Now, how do I cancel it? Well, if a joule is equal to a kilogram meter squared per second squared, let's substitute this in to there. So we've got a kilogram times a meter squared per second squared divided by, then we bring this down here, kilogram meter per second squared. And if you look at it, lots of stuff starts to cancel. Our kilograms cancel, our second squared cancels. We have a meter, we have meters squared here. So this meter goes away, and that essentially takes away one of these m's, and we're left with just m. All right. And that's 6.25 m, or meters. Is that what we wanted? Absolutely. We were looking for a height. We ended up with a unit of meters. That's a good check to make sure that we got the right number. Does that seem like a reasonable height? 6 meters is about 20 feet. Sounds like a reasonable answer to get for a question like this.